First of two videos on simultaneous equations. Simultaneous is a word that means at the same time. So there are equations that are happening at the same time. So this equation and this equation, if we're told they're simultaneous, it means the value of x in this one is the same as the value in this one. The value of y in this one is the same as the value in y in this one. So those two things represent the same number, and these two things represent the same number. These are all just linear ones, but we can have ones where we've got things being raised to a power as well. There are three methods to solve this, and in this first video I'll show you two, and in the second one I'll show you the other one. When you go on to do your degree in maths, which I know many of you are itching to do, you can do a thing called Gaussian elimination, where you can solve n variables if you've got n equations. So if you've got two equations, you can solve for two unknowns. If you've got three equations, you can solve for three unknowns. If you've got 100 equations, you can solve for 100 unknowns. Hours of fun. Wasted much of my youth doing that. Anyway, let's do the GCSE stuff. So the three methods you need to know are graphically, so drawing a graph, and that's similar to what we did a couple of weeks ago. I think it was lesson 32. And substitution, which I'm going to do in this video as well. And then the next video we'll look at elimination. So this is just a quick example of graphically that I'll talk you through, and I'm not going to do much detail on it. Essentially, if you've got these two equations, 5x minus x squared and 2x minus 1, we draw the graph for this equation, which gives me this straight line. We then draw on the same axes the graph for this equation. So we're drawing y equals 5x minus x squared, and we're also drawing y equals 2x minus 1. When you've got a quadratic and a linear, they'll cross in two places and you get two solutions. And you simply read these off. So we read this off. X is 3.3 and y looks to be about 5.7, and then for this one x is minus 0.3 and y is minus 1.7. So you simply read them off. It's a case of drawing the lines, seeing where they cross. That's your solution. You could have two linear equations, so you could have two straight lines, straighten that I hope, and where they cross there'll be one solution. So I'm not going to do too much detail on that because we did look at drawing graphs a little while ago. You're just going to draw them and look out where they cross over. Similar to what we were doing when it was solving it for when the equation was equal to 0, we just looked where they crossed the 0 line. So for this one, we'd have 0, 0 and 5, 0 as my solutions for that. But now we've got two equations, so we just draw the two equations and we look where they cross. As I say, if you want a bit more detail on that, look at this YouTube video. That was lesson 32b, linear equations and solving them graphically. I'll look at a couple of these equations and just give you some examples and talk you through them. You could solve this A by doing some graphs. You can take x away from both sides and create the equation that y equals 8 minus x. And then also draw the graph of y equals x squared. You'd get a straight line graph and a quadratic that are crossing two places. Or you could solve it by substitution. If I know that y is equal to x squared, I can replace y by x squared and produce a quadratic x plus x squared equals 8. Move that around to create a quadratic, so I get 0 equals x squared plus x minus 8. So I've taken the 8 over there to leave 0 here, then solve this in one of the four methods that we looked at previously. I've got an example written out here for you where I've done C by substitution. So again, it tells me that y is equal to 2x squared. So I replace the y there with 2x squared because I know that y is equal to 2x squared. So if we look at what that produces x plus 4x squared equals 7. Again, I can take the 7 over to the other side. So I produce a quadratic equal to 0, and again, solve that using either the quadratic equation or any of the other three methods, whichever one you like. For j, I've got x and y being combined here, so decision is which one we're going to get rid of. I would say we get rid of the y, because I can easily swap this around to find out that y is actually equal to x over 2. So I can now put that in place of the y there and create a new equation which tells me that x squared plus 3x multiplied by x over 2 is equal to 10. Because I've replaced that y with what I know y is equal to. So in total, 3x times x over 2 is going to give me 1.5x squared. Don't forget the squared. So x squared plus 1.5 x squared, which came from 3x times x over 2, is equal to 10. You lot prefer decimals, so we'll change that to a decimal. 1 plus 1.5 is 2.5, so I get 2.5 x squared equal to 10. Divide both sides by 2.5, I end up with x squared equals 4. Very nice, because I can square root 4. Square root of 4 is 2, square root of x squared is x, so I've ended up with x is equal to plus or minus 2. Remember, when I square root something, it could be plus or minus. I then use these values of x, plus 2 and minus 2, in my original equations up there to find out the y value. So I get two answers. When x is 2, that tells me that 2y is equal to 2, so y is 1. So I get one solution, which is 2, 1. When I use x is minus 2, I get minus 2 is equal to 2y, so y is equal to minus 1, so I get the answer minus 2, minus 1. Okay, so that's solving simultaneous equations by substitution. Again, just a case of practicing. You probably want to do these two methods, graphical and substitution, in the exercise S and A, then come back after you've watched the second video and do the questions that require you to do the elimination. Good luck. See you later. Bye bye.